G'day. Yeah, my name is Eldar. I'm here today to talk a bit about network monitoring software or attacking network monitoring software. It's a bit of a mix between the theory, or I suppose what makes network monitoring a valuable target for attackers, but it's mostly about a journey that I went on while doing some research on network monitoring software. So some of it might be a little bit technical and in the weeds, but I'll sort of try to highlight the bits that are important. And if you don't get the code bit, just skip ahead, stay with me till the end, and it should all make sense. So start by talking a little bit about myself. I'm a lead security researcher with Senate Labs. I started my career as a developer. I did security administration or system administration for a while before I moved on to penetration testing, red teaming. I'm currently a security researcher full-time. I also do training at conferences where I teach the theory or broad introduction to how to hunt for vulnerabilities in software. Now, network monitoring software, for those who don't know, is essentially a central alert monitoring solution for your network. It'll analyze things like traffic or host service levels and give you alerts when something goes down, something isn't working, you're running out of disk space, etc. They're generally very complex systems because they have to deal with things like local resources on systems. They have to deal with all manner of different devices, all manner of different protocols. The users are typically your network or your system administrators, so it's a privileged user base, which is the primary reason why it's a juicy target. If you hack the admin, you have typically full access to the network or the system's Active Directory, etc. Because it's an ongoing system, there's usually active sessions that'll last for forever, right? So the admin will have the network monitoring system either in like a big screen in the network operations center, security operations center, or they'll have a tab always open in the browser so that they can quickly switch to it, do whatever activity needs to be done. And the other thing is it has broad connectivity. So usually it's located somewhere central in your network because it needs to monitor resources across your network, or at least interconnectivity between various parts of your network. So you put all of those things together and you have a pretty valuable target for an attacker to go after. The other thing is, if you do compromise the network monitoring system itself, you can do things like ongoing key logging to catch admin passwords as they're logging in. Or, hopefully they use two-factor authentication, unique passwords for the NMS system, etc. In reality, that may not be the case. Even if you can't do that, you can usually leverage other things such as Nagios plugins to potentially execute commands, arbitrary commands, on the system that's being managed by the network monitoring solution. You might be able to silence an alarm as you're installing a rootkit and rebooting a server. So there's a lot of value for an attacker to persist on a network monitoring system. Specifically today, we are talking about LibreNMS. LibreNMS is an open source network monitoring solution written in PHP. It has a lot of functionality, a lot of extensibility. It's relatively popular, I would say. Very active development, pretty polished and mature piece of software, and it supports all manner of devices as well as local resource monitoring on the actual devices. It has a bunch of stuff that I've never looked at, like the native iPhone app, native Android apps. It has billing support, so you can generate bills for the network based on usage and transfer, etc. I've really only looked at it from a code quality perspective and then leveraged that further on into vulnerabilities. And it runs in your browser. It looks like this. It has a bunch of devices registered within its configuration, and then it tracks things like, available CPU, available memory, disk space, transfer rates between the devices, etc. And it can capture this a number of different ways. So, Nagios I mentioned before, SNMP, or collect data. I actually don't know all the ways it can collect data, but at the end of the day, it just generates this type of graph, and then the sysadmin can kind of look at that and go, oh well, there's too much color here. This is bad, and react to it. So in the past, I have also looked at LibreNMS. 3 years ago, I guess, 2016, I found some vulnerabilities: authenticated SQL injection, and information disclosure. The information disclosure is actually somewhat mislabeled. It's actually command line argument injection, but the commands that you can inject arguments to don't have any useful arguments that you can leverage for code execution. So you can just do minus version and get the relative version for the software, which may then give you offset or information about the operating system, the hardening version, etc. Altogether. I've also in the past looked at Cacti, which is a competing platform, where we found remote code execution via SQL injection, so sort of second order local file include, I suppose. Also a pretty fun bug. In addition to that, and it's not covered in this presentation, I've looked at IP space management software, DNS control panels, various telco software. I quite enjoy looking at the sort of sysadmin tools because they seem not to have the security posture that you would expect. So, and they're highly valuable from an attacker's perspective. So if I can, research some stuff there, deal with the vendor, get the bugs patched, and make everyone more secure, then, that's good, and I get to have some fun along the way. So, testing this sort of stuff. So when you're looking at some software that you don't necessarily have in-house or you run all the time, you typically want to have a running system to evaluate and verify that whatever you find is actually exploitable. In the past, the installation of LibreNMS was not trivial. There's a lot of prerequisites because it's a complex piece of software. I never bothered going through the full installation. So the old bugs I found in the code, and then I went to the demo. They had like an online demo site, and I just verified the vulnerabilities there because most of my research before I became a full-time security researcher, when I was a pen tester, was done on my commute to and from work. I had an hour on the train, and that's where I did it. So connectivity was occasionally a problem because the train is moving and your 3G connection drops. And time was obviously limited, so I wouldn't spend, several hours installing software with download dependencies. So I would basically just skip the software if that was the requirement in order to validate the stuff. However, they now have VMs available. They have multiple VMs published for every release that they do. That means that testing across different versions is easier. You just download the VM, you spin it up, and you can start testing. It also means that production systems are likely to be VMs, because why go through the hassle of installing when you can just download the image, expand the disk, give it some more RAM, more cores, off you go. And that of course means that the default passwords of the VM, if you don't change that, nothing I say in this talk in terms of like the vulnerabilities matter, because some people can just log in as root. Right? Just don't do that. Please, default passwords are bad, we know this. So that's really the broad overview of network monitoring systems and why attackers look at them. And we'll really just talk about what I found, what I did with it, how I did it, etc. There's a bit of struggle, but hopefully you'll be able to follow this along. So a long time ago, more than 10 years ago, I was working as a sysadmin. I had to maintain some code bases that we had that I didn't write, and I was concerned about the code quality of the ongoing development. So I wrote a very simple script that used some regular expressions, and it would look at Git subversion in those days. We run as a subversion hook, and then just look for certain types of like, oh no, you really shouldn't do this. So very, very simple. And then over the years, I have built on this based on other tools, detection capability, my own experience, etc. So like I said, I used to do research on the train. So I would sit on the train, I'd have a code base, you know, I'd find something, I'd update the rules, and then the next day when I was looking at, or next week or whatever, when I'm looking at a different piece of software, I would then apply the learnings previously, and over the years, Groudit has improved a lot. It is an endless source of vulnerabilities for me. It's not like a complete source code review tool at all, but it's a pretty good starting point. So not so long ago, back before MITRE hit the initial 10,000 CVE ID numbers, I was kind of pushing to try to reach that number. So I figured I would try to increase the rate at which I identified vulnerabilities. So I took the knowledge that I had in Groudit and I made a new rule set that was really aimed at finding really like low-hanging fruit. I wrote a simple taint analysis engine based on the initial, so to say, it takes grep, feeds grep through Perl and back into grep for a very basic taint analysis. And we just focused primarily on like higher value bugs, SQL injection, remote code execution, no cross-site scripting, no CSRF, no information disclosure. It was just sort of high value bugs. And then I wrote another script that would crawl GitHub and find like the most recently updated repos, the most popular repos. And then overnight it would clone and scan that code, generate a report, and then depending on how busy I was, I'd review it at some stage during the week. So I call this Flatline from the Flatline construct from Neuromancer. Not sure if it's really up to the standard, but you know, I left this running for 2 years until GitHub blocked me, and it found more bugs than I had the capability to review. So I did the numbers on this not too long ago, and over that 2-year period, it found about 94,000 vulnerability candidates in the code bases that it scanned. Now, a lot of those weren't valuable bugs. It's, you know, people's homework or whatever, or it's a CMS system that has 2 users. And a lot of them are duplicates because an actively updated repo might get scanned every day for a whole week. So it's not it's just a number. Counting vulnerabilities isn't necessarily a good metric, but it sort of goes to show that this was me doing it for fun. I can guarantee you that people that have financial interests in hacking software, they're absolutely doing this probably at a far larger scale than what I do. So it's sort of important to remember that you can't just think that because something is open source or because something hasn't had a vulnerability in the past that it won't be looked at. So I also recently released a new version of Groudit, and because I couldn't be bothered updating the framework to do this again, I just threw the flatline code in Groudit. It would need a little bit of elbow grease if you wanted to set it up yourself. If you do that, don't do what I did and scrape GitHub, use their API so you don't get IP banned. Just anyway. So, like I said, in 2016 I looked at LibreNMS, and then in 2018 it showed up again in my automated scanner in February. Now, these 2 lines of code in particular, I remembered from the first time when I looked at it, and I know that these are both false positives. So the first one that's in red, the line above it, verifies that it's actually a numeric value. So you can, well, you could say it's a insecure direct object reference, but it's not particularly useful in this case. And the other one actually uses a whitelist. So even though it's doing super global user-controlled variable concatenated within a process call, it's actually safe. It's bad practice, but it's safe. So anyway, it showed up again. I'm like, yeah, it's been a while. There's probably new code in here that might have new functionality, or maybe I missed something last time. I should audit this again. So I put it on my to-do list. But at that period of my life, I was far too busy to go back and revisit a large code base. So I kind of just left it. And then earlier in this year, I had an opportunity to go back and revisit it. I've been wrangling with a particular annoying custom pool implementation in C, and I needed a break and something different, so I went back to PHP and admin tools. So at this point, I started I grabbed a copy of it, and I started reviewing the code, not just for the really low-hanging fruit, but more overall for things that are potentially interesting. And this one caught my mind, or my eye, right? So it's a shell exec, so they're running a command, and the command is rrd command. Okay. So typically when you find something like this, where it's just a variable, it means that they're doing a bunch of string concatenation to make this variable contain a larger command and then running it. So we need to work out how is this command constructed. So we go and look at this file, which is an include file, so it's not a direct PHP script in itself. And we see there's a couple of things here. First off is it takes all these variables that come from the URI, which is the get variables, and then it turns that into its own array, and then it sets some default things. And obviously there's an interesting fix me remove these. I'm not entirely sure, but that could be an indicator that this is like legacy code, and we probably want to see where this ends up. So we take note of those, okay, because essentially at this point we know that user-controlled variables or user-controlled input is going into these properties. And then we jump down and we actually find the code that we saw in the initial scan. And we see here that there's a call to rrd tool graph, and then if the height is bigger than 99, then it runs the command. And at this point I sort of jump to the conclusion that the rrd tool graph function constructs the command as a global rather than as a return value, and it's probably just more bad development practice. So most likely this thing it's when we want to generate a graph, and we will take some options. These options are probably the properties for the graph that we saw earlier, things like the width and the height, which are user-controlled values, and then running a command. That seems like a very good candidate for command injection. So at this point, I stopped reading the code, and we just jumped straight into the web interface to see whether or not, this is something feasible. And we see at the top here, we have these type of user-controlled values, the device, from, to, graph type, etc. So that seems like a likely mapping that the graph values or the variables that we saw kind of corresponds with what we're seeing in the URI. And we can also see that in this case, it's not actually using traditional get variables with like the ampersand, but rather a slash. So we know it has its own handler for dealing with user input in this particular way. And the code that we saw earlier is if in cases where the URL doesn't follow this format, it will convert it internally into the same representation. And then that way the developers can keep consistent interface in their code. But how do we actually know what's going on here? Well, luckily, the developers have left debug functionality available literally throughout all of LibreNMS. So you can either there's typically be a button to say, yeah, show what's going on in the background, or you can enable debug just by adding debug to the URI. So when we then go and look at the commands, well, we see here, it's calling rrd tool with a graph, and there's a whole bunch of data being provided, and it also shows the output of the tool. So this will probably let us very quickly determine whether or not, if we put a command in here, we should be able to see both that the command is being injected, but also hopefully the output should give us the output of the command, and that's it. We can go home. So I jump into burp, which gives me a lower layer view of what's going on. I add one of the variables that I had from the code that seemed friendly. So I take title, because title is something that usually wouldn't be filtered too hardly, right? It's not going to be converted to an integer or necessarily restricted for all sorts of characters that are considered bad or illegal. So I add that, and I notice that the title I gave it is not in the RRD tool command. Okay, so it didn't get injected, but also notice that it does get injected as a parameter to a different URI, which is graph.php. So maybe there's more than one type of graph in this thing. So let's go see what graph.php does. And it generates the actual image. I just follow the URI. I'm not manipulating anything at this point. We see we get a PNG back. Okay. But I would like to know what's actually happening here. And like I said, luckily, it has the feature we can just add debug. So you just throw debug in the URI. Here's all the debug stuff. It shows stuff that's not related, like querying the database. And we can see that all of the the queries are parameterized, so we couldn't do SQL injection, which is also handy to know that we don't have to go down that rabbit hole. And then we see the command that it's running. Okay, that's good. But we see that here it's searching, but it's not showing up the title that we gave it. So again, the title is not being injected. Okay, before we go back and try to work out why title isn't being injected or included, because I'm pretty sure that was one of the variables, let's try one of the other variables instead. So this one, I didn't put we see we add semicolon ID to height. It shows up here, and we get some output. All right. Now you can see W data. Maybe we had an injection here. But I would imagine that if we had an injection, the remaining bit of code here should have caused an error, and we didn't get an error. So probably didn't do a successful injection. Also, we'll see that on closer inspection, the W data is actually the file and group ownership of a file. It's not the output of the ID command. So we didn't have or successful command injection. So let's do the usual brute force as you do as a pen tester. You're like, all right, well maybe semicolon is filtered, and semicolon got escaped, and so it didn't work. So let's try pipe character, ampersand, backticks, forks, environment variables, new line, command line injection, arguments, etc. Just run through the whole thing, and then sort of, one by one see what the output is. Maybe try combining multiple in case there is like a whitelist. And then I noticed this thing here, where if we do new line, ls, new line, it seems to have worked. We see ls gets injected. There's a new line being injected here, and another new line there. We see what appears to be directories being listed, and we see an error from the excess data, right? The -c here. So that kind of seems like it worked, but also at the same time, it's complaining about unknown function -c. Whereas if this was command injection, I would have expected invalid command or command not found, not function. So obviously at this point, we can say, well, it behaves as if it's a command injection. In the code, it kind of looked like a command injection, but it's definitely not command injection. So I guess I misclassified this bug. At this point, we need to go deeper. And the only thing to do is to start reading more code. So we can go back and we can see, well, the initial call was to RD tool graph before it then would call the command. And we'll see at this point, it's actually doing something else. And that is, we see here, first of all, it has the debug, shows the command return. Okay, well, that's great. I thought that came from somewhere else, but it's not. The other thing we can see here is it does a initialize and a build command, graph file, and we saw graph in the output from the debug. So this might really be where we are. And then it's doing an implode send command cmd, which is this. But of course the variable is cmd, it's not rrd cmd, which is the one that we thought we were injecting to. So we got to go deeper still. And so we can look at the RD tool initialize, and we see, okay, first it defines a bunch of pipes, standard in, standard out, standard error, and then we can see it actually spawns a process, and it's doing asynchronous synchronous processing. So at this point, it's like, okay, well, it looks like it is spawning maybe a daemon for the RD tool, and then it's using pipes to communicate. As we also see, it looks like it's running the command RD tool with standard in as the input. It looks like it's communicating through pipes to this thing, and it's not necessarily running the commands directly from the shell. Okay, well at that point, we aren't actually running commands at all. We are feeding commands or feeding data into a command, but it ran ls. That means something inside RD tool decided that I'm going to execute ls, or I'm going to do something equivalent of ls and then feed you back the data. So in order to understand what's going on here, we need to shift sideways. So we can now look at RD tool. An RD tool is a round-robin database tool set. It's essentially just used to generate the fancy graphs, which you might have seen something similar in the LibreNMS screenshot that I showed. Now, RD tool is also very complex. It has a lot of different functions. It said that -c is not a valid function. Yeah, I think we're onto something here. And graph, yeah, we saw graph. Also, we can see that it does support bindings from Perl, Python, TCL, PHP, and it has remote control through a set of pipes. Okay, that sounds exactly like what's happening. So at this point, I started reading all of the documentation for RD tool. I didn't actually delve into any of the code. All of the documentation was sufficient. So we've identified a couple of things here. One of all is, the first one of all is we are calling functions. So we saw graph, we saw -c being complained as like not a function, but we're also seeing command line or function arguments like -c as an argument. So we can look at both the functions as well as the arguments to the individual functions. And I developed a whole set of different exploit primitives. So you can inject a function that will do information disclosure. You can inject a function that will do directory traversal, cross-site scripting, server-side request forgery, or server-side or cross-site port enumeration, a directory read, directory write, file read, file write. So these are all just generic things that RD tool can be convinced to do without necessarily being tied to a specific vulnerability. It's a bit like the notion of pop-up ret and SCH-based buffer overflow. It's like a standard technique. So just quickly run through the various ones that I found. So info, it basically just dumps the version and shows which tool functions are available. as well as the valid remote commands. And we'll see here, there's a valid remote command ls. So while that's not a function technically within RD tool itself, it is a function through the remote control interface that lets you do other things. So we have ls cd, make directory, parent working directory, quit. Quit is not particularly useful. You can't run, in this case you can't run DOS because it would spawn the process again the next time you try to do anything with it. Directory traversal, essentially you can, because it supports CD, you can just do cd dot dot cd dot dot cd, etc. As one of the functions. And we can stack functions. You can have multiple functions just separated by new lines. So we can combine multiple of these. Cross-site scripting. So we can do -f or minus image info, give it a string. The string has to have %s, %lu, but you can just, instead of doing image source, you just do script tags, whatever, and it will execute or generate cross-site scripting tags in the tool output. Server-side request forgery. So you can specify a daemon address, both as a Unix socket, but also as like an IP port pair. You can connect to it. I haven't looked at whether or not you could potentially make this connect to yourself and then feed it some interesting data to manipulate what the tool does based on what's in the database. I think that might be an interesting thing to look at. I will talk a little bit about what future research at the end. Directory read. So we already saw ls works. Now ls doesn't take any arguments, so you have to combine it with cd to go to wherever you want. Or you can do list. List will let you give an argument, but it only lists directories and RRD databases in that directory. So it doesn't list all of the files. Right. Directory write just comes back to the standard remote control function, like cd and ls. We have make directory. So we can just create a directory and then enter into that directory. File read, I have that in quotes because what happens is you give it a restore function. So you say restore space source file, which is supposed to be an XML file, and then output file. And so what will happen, it'll read, like if you give it etc password, it'll read etc password, and then it'll complain that there's no XML in the first line of etc password, and it'll just spit the first line back to you. So you don't get this, the full file information. Now I haven't checked whether or not you can do your typical XML attacks like external entities, which might be useful in order to extract more information. Could potentially be used with the remote debug daemon or the minus daemon cross SSRF variable to potentially manipulate the RD format that way. File write, that's really the only one that we care about. That's the one that'll get you remote code execution. So there's at least 3 ways I know of in order to create files. The create one will generate a binary file, but you can use that to potentially like corrupt the installation or config file to allow you to reinstall a particular piece of software like WordPress, if WordPress used RD tool. But the graph is the one that we care about because that will let us control both the file but also the content. And we can generate a polyglot file that is also a PHP shell, like so. So you would inject new line graph tmp test, which is the file it's writing to, give it a title of T, it doesn't matter, then give it a line definition, put some PHP in that line definition, and export it as a CSV file, and then new line at the end. And that will let you write a PHP file on the drive. And if you can write a PHP file on the drive, either inside the web root, you can execute it directly from the web root. If you can't, in this case, like we write into /tmp, maybe you can find a local file include or some other bug that will let you elevate the code from that location. So when I was reviewing this, I also identified a number of other bugs. So we found SQL injection, local file include, but it's a very restricted local file include. It has to meet a certain convoluted file name, but luckily we can control that file name, so it's not a particular problem for us in this case. Cross-site scripting, information disclosure, authentication, authenticated command injection, authentication bypass. So now that we have some primitives, we have a sequence of different bugs that are useful. We can then combine them. So we can take the unauthenticated RD tool syntax injection, combine that with a file write primitive to write a particularly named file, which we can then leverage in the local file include via directory traversal, which gives us pre-authenticated remote code execution. And it's simply just hitting a URL. In fact, you could also do this not just by directly speaking to the Libre NMS system, but through cross-site request forgery. So like I said, someone on the network will have this open in a tab, and you can just do like a watering hole attack or a phishing email. Someone clicks on a link, and you have code running on their NMS system. So we'll quickly do a demo of this attack. So I have a script here. I'll push this to GitHub later today. So you just give it the URL of the Libre NMS. I have that running here. I'm not logged in. I don't have any active user sessions, etc. The only caveat with the way I've written this this exploit is you need a user to have logged in at least once for the cache directory where I'm storing the PHP script to be written. That's not a problem. You could just write to /tmp instead, but this is the way that I did it. So it just takes a URL. What it does is it'll do a combination of different bugs. This could be a lot simpler, but I wrote this to submit to the developers so they could see how the entire bug chain and the different bugs interact. It does an information disclosure to find the local path on the drive where Libre NMS is installed. So if you didn't use the VM and it wasn't necessarily installed in /opt Libre NMS, but rather /www or something, it would always find the correct path. So it would always inject it into the cache directory. And then it does the command injection or the syntax injection to write the file primitive, and then it does the local file include to access it as if it was a web shell. So we simply run this, and we can see the output here of when we see the time is that's part of the CSV value. So can't get rid of that, but it's essentially because it's a polyglot. So we can then just copy paste this URL pretty simply, and we can hit that through curl. And instead of ID, we'll run uname -a. Thank you. And you see the output there. So very simple command execution through local file include. All right. But that's running commands as the web user, which is, it's good, but it could be better. So we'll look at privilege escalation. And this is not part of the exploit because it requires you to wait overnight. So essentially the www data, or the web user, belongs to the Libre NMS user group. And the LibreNMS group has write permission on the file opt_librenms_daily.sh. And that's a script that's executed from crontab daily. If you go and look at the crontab, it says in big letters, do not disable this script. I don't actually know what will happen if you do, but anyway, that runs as the user LibreNMS, and the user LibreNMS has sudo permission to run any command as root without password. But like I said, if you didn't change the default passwords from the VM, you can just SSH in and run commands as root anyway. So you don't have to go through all of the convoluted steps. And then, sort of to wrap it up a bit, the disclosure process, I reached that to a personal connection. So hi Paul, if you watch this on YouTube, thanks. He walked me through sort of the correct process for contacting the team, correct email address, PGP keys, etc. LibreNMS responded well, like they did the first time as well. Due to some of the complexity of the RD tool, syntax injection, and in some cases, the patching didn't always cover 100% of the use cases, etc. I think we went through 3 rounds of patching before the final version was released that's safe. They also requested a 30-day grace period after the patch had been available, which we agreed to. I don't think it actually adds any value. It's an open source product. If someone sees the patch, they can go and reverse engineer it and write the exploit, which of course somebody did. There's a Metasploit module. This is for the collectd command injection. This is the authenticated command injection. It's not the pre-authent file create primitive. So yeah, if you hadn't, but again, this is the sort of stuff that can be attacked through an active user having the browser open. So if you run LibreNMS or CactiNMS, please keep up to date on patches. Actually, LibreNMS supports automatic patching, which is really good. Unfortunately, most web software don't do this. Also, we got some upcoming Cacti bugs. There's some SQL injection, unsafe deserialization. The deadline on this actually expired yesterday, but the patch isn't out yet, so I'm withholding the details for now. There will be some advisories coming out for this. They're both authenticated though, so it's unless it's CSRFable, they're not so critical. And Nico dropped this a while back. It's typecast authentication bypass in Centrion, which is another PHP-based network monitoring solution. Yeah. There should be another set of bugs coming. I had a whole bunch of bugs in Centrion, but unfortunately the file corrupted, so I'm going to have to redo that work. But unless they patched it, there should be some deep bugs there as well. Further research, so I got to go back, I got to redo Centrion. I'd like to look a bit deeper at RD tool to see, could you potentially abuse that through things like memory corruption through spoofed SNMP packets or something. It's a pretty big beast, so I think the complexity tends to breed vulnerabilities. And then there's a whole bunch of other tools that you can integrate with, like LibreNMS, or in general are being used for this type of network monitoring activity. So when I have some more spare time, I'll probably eventually dig into those. So yeah, in conclusion, system administration software generally represents a very juicy target. They may not have the secure code base they appear to have. In general, it's not end-user software, so it doesn't get battle-hardened the same way as Microsoft Word would, or the Windows kernel. Always assume that people are researching high-value targets. The cost to finding 0 days is often substantially less than people think. If you do that scale, like I did with grep, you can find large number of 0 days with relatively little effort. Bug hunting can be fun. It's also very frustrating, but always very rewarding. So thank you.